Welcome to this revision walkthrough for question 2 of data mining and data warehousing. This is an optional question worth 20 marks across 6 parts, and it covers data warehousing from end to end. The definition of a data warehouse, the enterprise warehouse versus the data mart, the top-down and bottom-up build approaches, the 4 steps in warehouse design, and the OLAP family, including ROLAP and MOLAP. Let's get into it. Before we dive in, let's look at the roadmap. Question 2 has 6 sub-questions. Part A worth 2 marks asks you to explain the term data warehouse. Part B worth 4 marks asks you to contrast the enterprise warehouse with the data mart. Part C worth 4 marks asks you to distinguish the top-down approach from the bottom-up approach. Part D worth 4 marks asks you to describe the steps in a data warehouse design. Part E worth 2 marks asks you to explain online analytical processing or OLAP. And Part F worth 4 marks asks you to contrast 2 types of OLAP, relational OLAP and multidimensional OLAP. Let's tackle each one in turn. Part A is worth 2 marks and asks you to explain the term data warehouse. Here's the classic Inman definition, and it's worth learning word for word. A data warehouse is a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of management's decision-making process. In simpler terms, it's a central repository that consolidates data from multiple heterogeneous sources for analysis and reporting, not for everyday transactions. 4 keywords carry the marks here. Subject-oriented means it's built around business subjects like sales, customers, and products, rather than around individual applications. Integrated means it combines many sources into one consistent, conflict-free view. Time-variant means every value is tied to a time period, which enables trend analysis. And non-volatile means once the data is loaded, it stays stable and historical. It isn't updated or deleted like data in an operational system. Memorize those 4 traits, and this is an easy 2 marks. Part B is worth 4 marks and asks you to explain 2 data warehouse models, the enterprise warehouse and the data mart. Let's start with the enterprise warehouse. It holds all the data spanning the entire organization, every department, every subject. It's stored on large enterprise-class servers and can run into terabytes or even petabytes. It holds years of detailed historical data at the lowest level of granularity, and it serves users across the whole company as one central source of truth. The trade-off is that it's expensive, slow to build, and needs heavy upfront planning. Now the data mart. This is a small warehouse built for a single department or function like finance, sales, or marketing. It holds a department-specific subset of the enterprise data. It's cheaper and faster to build and easier to maintain. A data mart can be dependent, meaning it's fed from a central enterprise warehouse, or independent, meaning it's pulled directly from operational sources. In one line, enterprise is broad and central, while a data mart is narrow and departmental. Part C is worth 4 marks and asks you to distinguish the top-down approach from the bottom-up approach to building a data warehouse. These represent 2 schools of thought, Inman's centralized plan versus Kimball's incremental marts. The top-down approach associated with Inman builds one big enterprise warehouse first and then carves departmental data marts out of it. The advantages are a single, consistent source of truth across the organization and a clean data model from the start. The disadvantages are that it's expensive and slow to deliver first value, and it needs heavy upfront design and commitment. The bottom-up approach associated with Kimball builds individual data marts first, and then integrates them using conformed dimensions into a virtual warehouse. The advantages are quick wins since each mart delivers value fast, and it's cheaper, lower risk, and more agile. The disadvantages are the risk of inconsistency between marts, and the need for discipline around conformed dimensions to integrate them properly. Here's a memorable one-liner for the exam. Inman builds the house first, then the rooms. Kimball builds the rooms first, then the house. Part D is worth 4 marks and asks you to describe the steps followed in a data warehouse design. There are 4 progressive phases, moving from understanding the business to tuning the physical store. Step 1 is requirements gathering. Interview business users and managers to find out what decisions they need to make and what data they need to make them. Step 2 is conceptual design. Build a high-level model of the business, typically a star or snowflake schema of facts and dimensions. Step 3 is logical design. Translate that conceptual model into specific tables, columns, keys, and relationships for the target database. Step 4 is physical design. Decide on storage, indexing, partitioning, and aggregation so the warehouse performs well at scale. The order to recall is requirements, then conceptual, then logical, then physical. And the key insight to remember is that business drives design. The warehouse is built around the questions users ask, not the tables the source systems happen to have. Part E is worth 2 marks and asks you to explain the term online analytical processing, or OLAP. OLAP is a technology that lets end users interactively query, analyze, and explore multidimensional data at high speed. Where OLTP handles day-to-day transactions, OLAP sits on top of the warehouse and powers reporting, dashboards, and ad hoc analytical queries. The key mental model here is the cube. Data is pre-modeled into a multidimensional cube. The cells hold measures such as sales revenue. The axes are the dimensions you slice by, like time, region, product, and customer. And the operations available are roll-up, drill-down, slice, and dice, all performed in seconds. The defining feature to remember is fast aggregation. Users can slice and dice millions of rows in seconds, which is why OLAP is described as the analytical engine of the warehouse. Part F is worth 4 marks and asks you to describe 2 types of OLAP: Relational OLAP or ROLAP and Multidimensional OLAP or MOLAP. ROLAP stores all data in relational tables using a star or snowflake schema, and each query is translated into SQL on demand. MOLAP stores data in a proprietary multidimensional cube with every combination pre-computed in advance. Let's compare them across 5 criteria. On storage, ROLAP uses relational tables, while MOLAP uses a proprietary cube. On aggregations, ROLAP computes them on the fly or from summary tables, while MOLAP pre-computes them for every combination. On query speed, ROLAP is slower because it relies on complex SQL, while MOLAP is very fast, often sub-second. On scalability, ROLAP handles massive datasets well, while MOLAP cubes hit a size ceiling. And on load and build time, ROLAP is incremental and fast to update, while MOLAP takes longer because the cube must be rebuilt. In short, choose ROLAP when you need scale for huge data, and choose MOLAP when you need speed and the data fits comfortably in the cube. Let's wrap up with the 6 key takeaways from question 2. Part A data warehouse is subject-oriented, integrated, time-variant, and non-volatile. Those are Inman's 4 easy marks. Part B, enterprise means broad and central, while a data mart means narrow and departmental. Part C, Inman means warehouse first, then Marts, while Kimball means Marts first, then integrate. Part D, the design steps run requirements, then conceptual, then logical, then physical. Part E, OLAP is the analytical engine of the warehouse, enabling fast, interactive, multidimensional queries on cubes. And Part F, ROLAP means relational tables and scale, while MOLAP means pre-computed cubes and speed. Memorize these 6 points and question 2 is fully covered. Coming up next is question 3, covering item sets, support, confidence, and the a priori algorithm.